everyone, I am Ashni Joshi, and today we're going to be talking about two renewable sources of energy, namely hydropower and geothermal energy. So let's get started. Hydropower and geothermal energy. So the first thing we're going to learn is how we can get electricity from water. So when you think about electricity from water, the mechanism of obtaining this is very similar to how we got wind energy. If you recollect, when there are fast blowing winds and there are, say, windmills in that area, then due to the kinetic energy of the wind, the windmill's blades, they rotate and they generate electricity. So now the mechanism is same, except right now, instead of air, we have water. And instead of it just flowing, we're gonna make this water flow from a height to the turbine, the wind blades in case of windmills, and for electricity from water, we're gonna use turbines. So let's get into it. Water collected in dams is made to flow at a great speed. So dams, if you know, dams are basically places where we collect water and we make this water flow at a great speed by dropping it from a height, and we generate electricity through that, which we learn how we do it exactly. When falling, the water possesses kinetic energy. So I spoke about kinetic energy in my last video, but I'll do a small recap for you. Basically, the formula for kinetic energy is half mv squared, and anything that is in motion will possess kinetic energy. So since this water is falling or flowing from a height, it will possess kinetic energy. And now let's see how we use this kinetic energy to our benefit. More the flow of water, more will be the kinetic energy. We know that, right? Because if we take more water, then it's like we're taking more mass. And kinetic energy is half into mass into velocity squared. So more the mass, more the kinetic energy. That's obvious, right? This kinetic energy is made to fall on the blades of turbines, which convert it into electrical energy. So these turbines are the blades of the windmill form of hydropower. Turbines are basically, they also have blades, but when the water falls on them, their blades also, they rotate. And now the turbines possess kinetic energy. And the turbines then convert this kinetic energy to electrical energy. We know energy can be converted from one form to the other. So that's exactly what turbines do. They convert it into electrical energy so that we, you and me, can use it as electricity in our homes, in our schools, in our offices, and whatnot. This power produced from water is called hydroelectricity. So now this was how we got electricity from water. If we make water fall from a height and it comes on a turbine, the turbine rotates and then it converts the energy, we got electricity from water. And this phenomenon is called hydroelectricity, because hydro means water and electricity is electricity, of course. So let's see how exactly these turbines work. On the left is a picture of a turbine, how a turbine looks actually. And on the right is the mechanism of it. So the reservoir is basically where we will store water, and this intake gate is the channel through which water will flow. So after the collection, this gate will be opened and this water will go through this path. And when it comes on the turbine with a very large speed, it will force the turbine to rotate in a particular direction, be it anti-clockwise or clockwise. And when the turbine rotates, it generates kinetic energy. And this kinetic energy is converted by the turbine to electrical energy. And then, of course, the water goes back into the river. Now let's come to the second form of renewable energy we need to learn, geothermal energy. So I'm sure you've heard of wind energy, solar energy, hydropower a lot. But geothermal, this seems like something rare. Like, we have not heard too much of this, right? So let's learn what it is. And let me tell you, the mechanism is very similar to wind and hydropower for this one too. Geothermal energy is a type of renewable energy taken from the Earth's core. So you might ask, what is the Earth's core? How can we get energy from that? So basically, if you look at this picture on your right, where my cursor is, if you take the Earth and you peel it like an onion, and you take it as layers, then the uppermost layer is the crust, where we are, me and you, we're on the crust, we're on the uppermost part of Earth. Then we get the upper mantle, then the lower mantle, then the outer core, and the inner core. And as we go lower and lower, the temperature and the pressure, they keep increasing. And because the temperature is so high, that means, of course, we can get energy from there, because temperature, by definition, refers to the kinetic energy of molecules. So if the temperature is high, of course, it will have more energy. And the core, which is the innermost part of Earth, that is the hottest part of the Earth. It is at a temperature of 6,000 degrees Celsius. And you might ask, why is the core so hot? Why is the core not really, really cold? Why isn't it minus 2,700 degrees Celsius? Why is it 6,000 degrees Celsius? The answer to this dates back to the Big Bang theory, how the universe came into being. When our planets formed, when Mercury, Venus, Earth, Mars, Jupiter, or when all of it formed, the situations were such that the temperature and pressure were really, really, really high. So as matter formed, as our Earth formed from small, small particles, it was the temperature was so high that the core of Earth, the temperature of it had to be high, because the Earth was born only in a situation where the temperature was so high. Anyways, I took a little bit of tangent there, but let's see how we get geothermal energy from this core. This thermal energy is stored in rocks and fluids in the center of the Earth. So from the crust up till the core, there are certain rocks, there are certain fluids, there are certain natural reservoirs. So they are very affected by this heat, and they are very, very, very hot. So now we'll see how we can get electricity from this. How is electricity generated from geothermal resources? Geothermal power plants use steam to produce electricity. Now, this was what I was talking about. In wind energy, we used wind. In hydropower, we used water. In geothermal energy, we're going to use steam. Now, where do we get this steam from? So this steam comes from natural reservoirs of hot water found a few miles or below the Earth's surface. So if this is the Earth's surface and we going below and below, if we go like a few miles below, we can get natural reservoirs of hot water, which generate intense amounts of steam because they're very, very hot. So they generate steam, and we use this steam again to rotate a turbine and get electricity from the kinetic energy of the turbine. So basically, kinetic energy of steam transferred to kinetic energy of turbine, transferred to electrical energy. The steam rotates a turbine that activates a generator which produces electricity. We're using it through a generator. We're converting it through a generator. So now let's see how exactly the mechanism of geothermal energy is. So step one, heat from the Earth's crust has to create steam, right? And step two is how we use the steam. So we collect the steam from the hot reservoir and we pass it on a turbine. The steam, because it's so hot and we'll of course pass it at a particular speed, will rotate a turbine. And you know what happens after this. This turbine uses its own kinetic energy and converts it to electrical energy. And then of course we inject the water back into the ground. And yeah, that was how geothermal energy works. Thank you. that was it from this video. I hope you understood everything. Look forward to seeing you next time. Bye.